Hello, today I'll be showing you how to solve some rational inequalities. So the first example is x squared minus 6x plus 8. And this is all divided by x squared minus 14x plus 48. And this is all greater than 0. So usually when you have something like this, a quadratic, it's best to factor, if possible, both the top and the bottom. So let's do the top first. What are two numbers that multiply to 8, but then add up to negative 6? So the answer is negative 2 and negative 4. So we can just factor that as x minus 2, x minus 4. And then what are two numbers that multiply up to 48 and add up to negative 14? And it's negative 6 and negative 8. So we can do x minus 6, x minus 8. And this is greater than 0. So now, the best option to do right now is to look for the critical points. And usually the critical points are what we can see right here, are usually the zeros of each polynomial. So for the top part, the critical points will be 2 and 4. And on the bottom, the critical points will be 6 and 8. So those are our critical points, and we will come back to them later. The next step is to draw a number line like this. And we just want to plot every single critical point on this number line. So let's just write 2, this will be 4, this will be 6, 8. So when we know the critical points, we have to figure out if this entire expression, where it is greater than 0. And the best way to do that is by plugging in points. So we can't plug in points which are 2, 4, 6, or 8, because if we plug in, let's just say 4, plug in 4 for x, 4 minus 2, and then that's 2, and 4 minus 4 is 0, 0 times 2 is 0, and 0 divided by anything will be 0, and 0 is not greater than 0. So we can't plug in any of these points on the top, but how about the bottom for the 6 and 8? If you plug in 6 or 8, the bottom half of this expression will become 0, and you can't divide by 0 because it's undefined. So that's why these will be open circles, meaning that it's not equal to them. X cannot be equal to them. So we plug in points. Let's just say we want to plug in 0, because we have to find out the sign of every single area of our number line. So this is one area, we'll call it. This is another area right here, another area right here, and lastly another area right here. And the very left and the very right, these extend to infinity and negative infinity. So let's plug in 0 because it fits into this first bracket. So we have our original function, x minus 2, and it's x minus 4, and then that's all divided by x minus 6, and x minus 8. So let's plug in 0. We have 0 minus 2. We have 0 minus 4. We have 0 minus 6. and we have 0, minus 8. So we can calculate this. So 0 minus 2, negative 2, multiplied by negative 4. So that's a negative times another negative. And then negative 6 multiplied by negative 8, which is another negative multiplied by a negative. So that'll be positive divided by a positive. And a positive divided by positive is a positive number. So in this bracket, we'll write that this is positive, and we'll write it in pink, denoting it as positive in this area. That means that from negative infinity all the way up to 2, but not including 2, the function will be above 0, or positive. Let's try 3 now, because it's in between 2 and 4, and it's in this bracket. So if we try 3, let's do 3 minus 2, and 3 minus 4 divided by 3 minus 6, and then 3 minus 8. So 3 minus 2 is 1, so that's a positive number. And then 3 minus 4 is negative 1, which is a negative number. So we'll put a negative sign to denote that. 3 minus 6 is a negative number. 3 minus 8 is another negative number. And so that is equivalent to a negative divided by a positive. Negative divided by positive will equal a negative number. So we can say that in this area, between 2 and 4, there will be a negative sign. The function will be negative between 2 and 4, but not equating 2 and 4. Next, let's try between 4 and 6. Let's do 5. So, we can do the same thing. We'll do 5 minus 2. And then we'll do 5 minus 4. And then we'll do 5 minus 6. And then we'll do 5 minus 8. So this can be shown as a positive, 5 minus 2 positive, 5 minus 4 positive, divided by 5 minus 6 negative, 5 minus 8 negative, and a positive divided by a positive, because a negative times another negative is positive. Positive divided by positive equals positive. So this would be positive between 4 and 6. Now we just continue. Let's try 7. Seven is in between 6 and 8. So we'll do 7 minus 2, and then 7 minus 4 divided by 7 minus 6, and 7 minus 8. And so you should be pretty quick with this now. Be positive, 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 negative. And that should equal positive over negative, which is a negative. So between 6 and 8, it'll be negative. Now let's try between 8 and infinity. Let's just try 10. That's an easy number. So 10 minus 2, then 10 minus 4, then 10 minus 6, and 10 minus 8. Nope, 10 minus 8. 10 minus 2, positive, 10 minus 4, positive, 10 minus 6, positive, 10 minus 8, positive. These are all positive, which means positive divided by positive equals another positive. So now we can see that this function will be positive between negative infinity to 2, then 4 to 6, and 8 to positive infinity. And we don't include any of these critical points. So we can say that the intervals in which this original problem in green is true, we can say that it's true between negative infinity to 2, and we use parentheses because we say it doesn't include it. If we were to use brackets like this, that means we say it includes 2, but we do not include 2. And then we union it. It's the union. And then we say it's 4 to 6, and we don't include them because they're the critical points. And then we union them again, and we say 8 to positive infinity. And this is our answer in interval notation. Let's try another example. The next example is x minus 3 multiplied by x minus 1 divided by x plus 2 squared. And this is less than or equal to 0. So how do we do this? First, identify the critical points. So this is actually factored for us. So our critical points for the top will be 3 and 1. And our critical point for the bottom will be negative 2. So we'll just highlight that. Next, we have to create a number line and write down our critical points. But this time it's different because you can see that this is a less than or equal to sign. When there's an equal to inequality, we might be able to include some critical points. So let's just write down, but we'll check them later. Let's just write down negative 2. That's one of them. Positive 1. Positive 3. Those are our critical points. And so now we check between each critical point. So between negative infinity and negative 2, let's say negative 3. So let's rewrite our original expression. We have x minus 3, x minus 1 divided by x plus 2 square. So we try negative 3. So negative 3 minus 3, and then we have negative 3 minus 1 divided by negative 3 plus 2. Oh, negative 3 plus 2, and we square that. Okay, so the way we do this is we do negative 3 minus 3, which is negative 6. That's a negative. Negative 3 minus 1, negative 4. That's a negative. And then negative 3 plus 2 is negative 1. But you have to square it. So negative 1 squared is negative 1 times negative 1, which is positive 1. So that's positive. And the top, negative times negative, positive. So this is actually positive over positive, which is a positive number. So we can figure out that this is positive here. Now, let's try another critical point. We'll do between -2 and 1. So let's just say 0, because 0 is an easy number. 0 minus 3 multiplied by 0 minus 1, and then 0 plus 2, and then we square that. So 0 minus 3, negative number, 0 minus 1, negative number, divided by 0 plus 2, which is 2, and then we square that. So 2 to the second power is 4, and 4 is a positive number, so that's a positive number. So now we have negative times negative over positive, which is positive over positive. So we get a positive between -2 and 1. Now let's try between 1 and 3. Let's try 2. So we plug in 2 for x. And so let's just say 2 minus 3 multiplied by 2 minus 1, and then 2 plus 2, square it. And so you don't have to write this all out, and you can do this in your head, but I'm just showing you. So 2 minus 3 is a negative number, 2 minus 1, positive number. 2 plus 2 squared is a positive number. And so we see that we get a negative over a positive, which is a negative number. So we know that this function between 1 and 3 will be a negative value. Let's try between 3 and positive infinity. Let's do 4. So yet again, put 4 for x. 4 minus 3, 4 minus 1, 4 plus 2, square the whole thing. So, you should be able to do this in your head now. Positive, 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 right? Which means it's a positive value between these values. So now we look at our original question. What are we looking for? We're looking for when 0 is greater than or equal to this entire expression. So now we can look for our critical points and see if it will be equal to. So let's see, what if we plug in -2 into this part? If we plug in -2 for x, this part right here, that will be -2. And so -2 plus 2 is 0, and then we square 0, which is still 0. But then we still have this top part on top of our 0, and you can't divide by 0. So that's going to be undefined. So this is an open circle because we cannot include it. And if we include it, it'll be undefined. Let's try 1 now. 1 minus 3. So 1 minus 3. And then 1 minus 1. And then 1 plus 2. And then we square that. So even though 1 minus 1 is 0, the 0 is on the top. It's not on the bottom. So it's okay if it's on the top, because then 0 divided by anything will be 0. It won't be undefined. So therefore, we can have x equal to 1. So we can color it in as a closed circle. This is called a closed circle. And let's just try 3 now. And so we do 3 minus 3, 3 minus 1, divided by 3 plus 2 squared. And the same thing can be said about this. 3 minus 3 will be 0, but it's on the top, so it can be included. Because it won't be undefined. So 3 will be a closed circle because we can include it. So now looking back at this part, this is saying Well, when is 0 greater than our function? Which is basically meaning, when is our function negative or equal to 0? So when is it negative? It's negative between 1 and 3. But it's also equal to 0 at 1 and 3. So that means our answer can be written as a bracket, because we can include 1 and 3. So we do 1, comma 3, and we include the 3 also. So therefore our final answer is brackets of 1 and 3. That's our final answer. Thanks for watching.